Okay, let's see if this works. The Pearson's are, this is an example. I'll go fairly quickly. This is my third time recording, so let's see if this works. In SPSS, you'll go to Analyze, and then Correlate, and Bivariate. Click those. And then when you're conducting the Pearson's are, and you'll also use the scattergram or the scatterplot so you could display your results graphically. First, what you'll do is follow those steps that I just mentioned, and then go ahead and look at two interval level variables. Your independent variable should be interval level, and your dependent variable will be interval level. So we'll just bring them over here and say that you believe that age will predict the number of years somebody let's look at the number of years with the current employer. Okay, so the older someone is, the longer they would be on the job. All right, and the beauty of the Pearson's are is once you put these over here, all you'll need to do is just make sure that Pearson's are is checked, and it should be on default, and then click OK. And then here are your results. So as we predicted, age and years, come right over to this column here, is related to years with the current employer, and it is indeed a positive relationship. With an increase in the numbers for your independent variable, like in age, it goes up. That corresponds with an increase in the number of years. The number of years go up in terms of the distribution of the scores or the years. For your dependent variable. So as the numbers go up for your independent variable and your dependent variable, and they correspond, the R will equal to a positive number, and we have that. So that's the first step in testing our hypothesis that age will lead to or predicts years with current employer. The second step is to see if we have statistical significance, and we can find that out right here. This is our p-value that we talked about in class. So in terms of this result right here, how much error or how much is this due to chance? If it's random, or can we say that we have support for our hypothesis? So if this is 0.05 or less, this number, then we can say for sure that we have support for our hypothesis of a positive relationship between years in age, or age and years, and the years with current employer. Okay, that age will predict the number of years somebody is on their current job. Okay, let me see if I can't get away from that. 6,400 folks completed these two questions, age and years. All right. And we see that we have significance. All right, and so now to display it graphically, we'll go to Graphs, Legacy Dialogues, and then come all the way down to Scatter. Okay, so of course you would not select the histogram if you're looking at the relationship between two variables. You would use the scattergram or scatterplot. Okay. From there, you should click OK and then go to Simple Scatter. There are a number of other things you can do, but we'll just do Simple Scatter. Define, and then just move your two variables here. We have age and we have, let's see if we can find it, years with current employer. All you have to do is click OK once you get those two variables over there. And we can see now that this is the results graphically. This is indicative, again, of a positive relationship. See how it slants to the right and up? So with each year, you have an increase, positive increase for the number of years with the current employer. Okay? So the computer does all that for you. And of course, if this was pretty close to, if it was a stronger relationship, and we have the regression line right through here, you can most of these dots would follow that line. All right, so you wouldn't see all of this. You just see something a little bit tighter in terms of the formation of dots. Remember, for each one of these dots, that's for each person who completed the question. The question, sorry about that. Okay. All right. So back to this. The question, age and years with the current employer. All righty. All right. So, and then of course, if all of this slanted in the opposite direction, that would show you a negative relationship. If it was no relationship, all these dots would just be random, and you really couldn't tell if we had a definite pattern. Okay. So this is a positive relationship, and it's a 0.6, I believe. I'll go back to our output. Okay, our Pearson's R. The R is equal to 0.62. Remember what I said about a perfect correlation? If we did see that line just going diagonal and it was just straight and you didn't see a lot of stray with the dots, age and years is perfectly correlated with itself, age and years. So that's why this 1 is here. So that'd be a 1, positive 1. Okay, that's a perfect correlation. But we're not interested in that. We're interested in age and this other variable, years with current employer. Okay? The higher this number goes, 0.6 all the way up to 0.9 and then 1, that means the stronger the relationship. If it goes lower, 0.6, say if we had another variable, age is related to another variable, not years with current employer, but something else that was a weak relationship, you might see something like Pearson's correlation. This R would be something like a 0.2. That's a weak relationship. A 0.1 is also a weak relationship. A negative relationship does not indicate a weak relationship necessarily. Okay, so we're just looking at the absolute value. What is this number, whether it had a plus or minus beside it, or nothing, or minus. Positive or negative, we're just looking at this value. How strong is it? So this is we won't say a strong relationship, but it's just somewhere in the middle, but it's not a weak relationship. Okay, what we would call a strong relationship, positive relationship, would be a 0.7, a 0.8, a 0.9, and a whole number 1. Positive 1, or a negative 0.7, a negative 0.8, a negative 0.9, or a negative 1 would also be considered a strong relationship. Okay, weak, it just means that you're going closer to the 0, and if you get to a 0 where, say if this were 0.00 or 0.020, if this is a 0 instead of a 6, the R would equal to a 0, and that would indicate that there's no relationship. So if you run your analysis between two variables and the results are R equals 0.0 something, so 0.02 or 0.01, then you can say that there's no relationship, essentially. Okay, anything with a 0.0. All right, that begins 0.0.